I'm pretty sure you have a project.
Fudge.
Uh-huh.
In math.
Sorry, you're in math. You don't get too many free days. You should be grateful for what you feel. Okay. So, still doing complex numbers. Does anybody remember what a complex number is? What?
We're graphing it.
Yes. Anybody remember what a complex number is?
An I.
Okay. Contained an I. What did I represent? Imaginary numbers.
Yes.
I remember this. Yes. Okay, so we were writing complex numbers in standard form. Does anybody remember what standard form was? Ooh.
Oh, my God.
So this was A plus BI. Okay, so it's Friday, so we were writing complex numbers in standard form. We were adding, subtracting, and multiplying. So today, we're going to start dividing, but we have to remember what this lovely little word means, conjugate, and nobody typically ever remembers what conjugate means. We learned about conjugates, I think, in section 5 when we were dividing by radicals. So it's the same kind of situation where I can't have an imaginary number in the denominator, just like we can't have a radical sign in the denominator. We have to like rationalize the denominator to move the square root up. We're doing the same thing, move the imaginary number up to the numerator. So, if you're given A plus BI, the complex conjugate is A minus BI. And it's vice versa, so if it started as A minus BI, complex conjugate is A plus BI. So we just change it from a sum to a difference, or a difference to a sum. Okay? So I'm going to say this is used to rewrite a division problem in standard form. Okay. So we're given this quotient, 3 plus 4i, divided by 5 minus I. Okay, so I have a standard form of imaginary number in the numerator and denominator. I need to write it in standard form, so there's just a real part and an imaginary part. I can't have like multiple. So I need to move the imaginary number that's in the denominator, this 5 minus I, up to the numerator. So we need to figure out what is the complex conjugate of 5 minus I. Any ideas what the complex conjugate of 5 minus I is? 5 plus I. So just like with square roots, we multiply the numerator and denominator by the conjugate. So 5 plus I is in the denominator. If I do it to the bottom, I have to do it to the top. So we have this whole thing. We need to basically distribute all of this out, since these are all different quantities. So it takes a little bit of math work here. So I'm just going to go off to the side and rewrite this. So let's multiply the numerator first. So we need to distribute or FOIL, or whatever you want to call it. Okay. So 3 times 5 is 15. I. 3 times I is, found it.
Yep.
Yay. Thank you.
My bad.
Okay. Yep. 4 I plus I. Yeah. I squared is what?
It's 4.
Negative 1. Right?
So it's
Mm-hmm. So we have 4 times -1, replacing I squared. I can combine like terms. This 3i and 20i is 23i. So I still have 15 coming down. This 4 times -1 is -4. I can now combine the 15 and -4 because those are like terms. Yeah. Okay. So did all that work, found my numerator, 11 plus 23i. So we're going to do the same thing with the denominator. So I'm just going to go over here, because I'm running out of room. Denominator, have to distribute as well. Great. This one's -5i. -5 squared. Okay. And we need to simplify. Yeah, so I have +5 and -5, so we go for that. And I squared is, yeah, so it'd be like -1, then 2 negatives and a positive, so it's just 25 plus 1, 36, so that's my denominator. So if I wrote this back together, 11 plus 23i is the numerator, 26 denominator. Yeah, so I mean, we already know how to multiply. It's just like you're doing 2 multiplication pieces in one problem, unfortunately. Perfect. Moving on. So this is actually easier than dividing the complex plane. So we can basically graph complex numbers, which are like a plus bi, on a complex plane. So typically when we graph, we have like an xy plane, that's what we would probably call it, or there's like fancier ways of saying it, rectangular coordinates or Cartesian plane or whatever you call it. Typically we have an x-axis, y-axis. That's what we're used to. Complex plane, no such thing. We have, this is the imaginary axis. Interesting. And then the horizontal is the real axis. So instead of the x-axis, y-axis, we have real, imaginary. So basically, if I'm given a plus bi, this is a horizontal shift. So if it was like 2 for the a value, I'm going to write 2. And if I have bi, this is the vertical shift. So basically, this a plus bi is acting like a quarter pair. Whatever the a value is, I'm going left to right. B value, I'm going up or down, and then placing a point. So all the numbers in complex form are just points on a complex plane. And we know how to plot points, so it shouldn't be too difficult. Crush points. Okay. I was gonna make sure Gracie gets it all written down before I move on. Sad. Dragon. That might be up or down. So when you make your graph, label this as real and label this as imaginary. Okay, I don't know if I spelled imaginary. Ah, doesn't matter. I'm not an English major here, people, so I don't spell correctly. So 4 plus 2i. What direction am I moving? Or where? Right. Okay, so 1, 2, 3, 4. And then 2i is only up 2. So 4 plus 2i is right there.
That's all it is.
Yep. Nice. The next one, negative 4i. What direction is I moving for negative 4i?
Just go over to the
No, I liked rain going down 4. That would be if it was just like negative 4. So that's
Oh,
being left in
yeah.
the real part for imaginary. So going down. We can plot these, right? We just have to remember, like quizzes and tests, real axis, imaginary axis, axis. I'm like forgetting to do that. Like being like, what the heck? Okay, so this is fantastic. I added this in because I'm crazy. You're welcome. Okay, so let's go back to Friday. What did I represent? Yes.
It's the 9th power. Can it technically be 4?
Mm,
You know how negative, like, I squared was 4? Or
Yeah.
negative 1? If you went to like 4.
yes. Yeah, you're on the right track. I just wanted to summarize how we're going to do that. Yeah. Because Gracie was saying I squared is negative 1. Yeah. Okay. I technically was the square root of negative 1. But in our case, we're just going to remember I is as simplified as we can possibly get. What about I to the 3rd power? So going off like the process that Gracie was saying, I can write I to the 3rd as I squared times I. Right, my exponents add up to the 3rd power. And we know I squared is negative 1. And I is as simplified as we can get, so this is just negative 1i. Okay? We could also do I to the 4th power. I to the 4th, I can write as I squared times I squared, which is just negative 1 times negative 1. And that multiplies to be 1. And we can keep going with this pattern. I can find I to the 5th. I mean, if I know I to the 4th is 1, I can write I to the 4th times I, which is just 1i. And then I can do the same thing. I to the 6th is I to the 4th times I to the 2nd. And I to the 4th was 1. I to the 2nd power was negative 1. So it's negative 1. So these are the ones that you have to remember because I to the 5th is now repeating back to I, right? I to the 6th power, oops, that should be a 6, is I squared, right? So it kind of goes in a circular pattern once you do I squared, I to the 3rd, I to the 4th. Going back to I to the 5th, that's the same thing as I to the 6th is the same thing as I squared. I to the 7th, same thing as I to the 3rd. Okay, so we're just repeating these 4 answers for any power of I. Okay? So what Gracie was saying, I can rewrite I to the 9th as multiple powers of I squared to make it just a little bit easier because then you have to like count how many negative 1s you have. I'm going to write them as powers of 4 because I to the 4th is just 1 and that's not like doing anything. So I can write I to the 9th as I to the 4th times I to the 4th and then times I. So that way my exponents add up to 9. Everybody with me on that? Okay, and then we know I to the 4th is 1. I to the 4th is 1. I is as simplified as we can. So I to the 9th is actually just I.
So I to the 50th would be I2.
How do you know that?
You just said I to the right is I, so I figured that I to the 50th is I2.
No.
Well, we're gonna do the same thing. How to rewrite I to the 50th power.
Because I just figure out if it's I squared, I to the third, or the
Yes.
fourth.
It has to be one of those four. Yeah.
And you can figure, it goes in,
Yeah. So how many times can 50 go into 4? Or how many times can 4 go into 50? A couple times, yeah.
So 45.
Yeah, so I just want the whole number. So I to the 4th. So 4 goes into 50. You said 12.5 times, but I'm just going to say 12 times. So I have a whole number. But then, if you remember the properties of exponents, 4 and 12, this multiplies to be I to the 48, basically. 4 times 12. But I need my exponent to be 50, so I'm going to multiply by an extra I squared. So that way my exponents add up to 50, which is my problem anyways. But this piece, this is a multiple of 4. So that's just like 1 times 1 times 1, 12 different times, which multiplies to 1. And then I know I squared is what?
maybe
Negative 1. So then 1 times negative 1 is negative 1. So I to the 50th simplifies down to just negative 1. Nice, right? Oh. Yeah. Okay, we have one last thing. Absolute value of complex number. Okay, so what is a complex number again? How do you write complex numbers? Beautiful. Okay, what do we typically remember of absolute value?
I didn't much care for it.
Oh, perfect. How do we define absolute value though?
Maybe easy to have open answers today.
Yeah, maybe.
Oh,
Oh. Yeah, I wouldn't be making it. Yeah, this was like way back in the beginning of the year. How we define absolute
I
value.
don't even remember Friday. Much less beginning of the year.
Yikes. Struggle is real. So, yeah. Absolute value, we had this symbol of just like straight lines, like inside it. So the symbol absolute value basically changes every number to positive. So if I have the absolute value of -2, that's actually positive 2. If it's absolute value of 1, it stays 1. So always positive numbers. We had another definition, so absolute value can be like represented in a story problem, and this is always the distance from 0. So this is what we should know about absolute value. Okay, this is the one that we need to focus on. Okay, this distance from 0 piece. So I want to say sometimes you might see, like they might write the complex number as the letter Z. So Z is just the complex number to uniform. I don't know why they use another variable, but in case you see that, I will probably always have this. Okay, so you have absolute value of a complex number. So remember, we could plot complex numbers as, like right here, a plus bi. So it's basically just point, but if I want the distance from 0, that's the distance from the origin. So I want to figure out this length right here. So this is the absolute value of a plus bi. Okay. So to find this distance, so this point could be anywhere on the graph, I could create a triangle to the x-axis. And how can I find the hypotenuse of a right triangle? What formulas or things do we about right triangles? Thinking back to geometry, there was one main one that we should all know. Had A's, B's, and C's with it. Probably got some squares on it. Yes. So we're going to use Pythagorean theorem. That's what that's called. Yeah.
Hey guys.
Okay. So this horizontal distance is A. Vertical distance is B, and we're going to basically be finding the C, or the absolute value of a complex number. So this is equal to the square root of A squared plus B squared. And we have a square root because if I was solving for C, I'd have to get rid of the square to square root of 6. That's where that comes from. So, anything right there, absolute value. Okay, so I'm going to find the absolute value of this. So I could plot my complex number. This is real, this is imaginary. Where would 5 minus 12y be? Right there. Okay. I don't think I actually made it down to 12, but it's close. Okay, so if they ask to find the absolute value, I want to find this distance from 0, 0 to this lovely point. So I can create a right triangle. So what is my horizontal distance? And my vertical distance?
12.
Woo! So I have a right triangle. I can solve the right triangle to find this C value if I do Pythagorean theorem. Yeah. So here I have C squared equals 5 squared plus 12 squared. Okay. Anybody know what that is? Solving for C.
That's 13.
13. Okay. So basically, the absolute value of 5 minus 12i is 13. That's the distance from 0. Yep. Pythagorean theorem.
How much you pay for that?
No, sorry. Okay, I can do the same thing with 17i. So where would 17i be on my graph?
17.
Where at? Like right
Oh.
up, level. Okay. So I don't know, like right there. So that's 17i. So basically, I'm finding the distance from 0. So this distance right here. Here's 17. I am a vertical distance. So the absolute value of 17i is just 17. It's 17 units away from 0. I don't even need to do Pythagorean theorem because I can't even create a triangle. Nice, right? That is all we're doing today. So you have 4.6b from Schoology. Woo! Hold your horses. Okay. I graded your test this weekend.
Nice.
Yeah.
Thank you.
Uh-huh.
back?
Yeah, you're not even gonna take a glance at it.
I'm taking advance, sir.
Oh, yeah. Okay, you're content with that?
Indeed.
The struggle is. Okay, hardcore. Hardcore, you don't wanna look at it to see what you can do better, what you need to say for next time.
Did I write?
Yeah, so you have a plus three minus two, right? Because that won't play for you nine. X times X is X, but not four X squared. Oh, so you need a number for the X value. But that one. Easy with like the right idea is. Yeah.
When we retake it, it's the same test.
They'll be different columns. It'll be the same structure format and everything. This is the X.
Yeah, this is the one.
Honestly,
we're gonna
75%
take.
is not a problem. Yeah.
There you go.
Okay.
This will be the one that I take, so we'll have to do it.
I like it. Is that okay? The test agree with that. Okay. Four after school. Because that's every day, you have to deal with whatever teacher that you're doing out in the class for.
I just don't know. It has to be this week.
I mean, I would like it because I was gonna put the grades in, like later on, after she ran the whole eligibility thing.